We are group R from section 5. I am Muhammad Omar and my group mates are Ali Rida and Kenan Fadi. So our group specification is design a 3-bit counter using an E flip-flop. So I will walk you through our process to design the counter first, and we will explain in further details with my group members. So here is the 3-bit counter first before we go through the steps. So we started first with a state diagram, considering an X input with a 0 and 1 input. So we started with the state diagram 0 for down and 1 for up. And after the state diagram, we got a state table for Q0 and Q1 and Q2 for a present state and for the next state too. And of course, an input X and 0 and 1. 0 for going down and 1 for going up. So after the state table, we got the transition table. We added the D flip-flop execution table to the equations so we can get the full picture. So we got D0 and D1 and D2. So after we get the transition table, we will do the key mapping to get the equations to implement the circuit. So we got D0, D0, this is the equation for D0, and this is the equation for D1, and this is the equation for D2. Also, of course, considering an X as an input for the counter to go up or to go down. So for the implementation, we after the equation we got to implement the circuit to control the flip-flops and the current input and the next output. So we divided the work to 4 parts: a clock enabler and a comparator and a passcode. So and a passcode and a door indicator. So my friends will explain the comparator part and the door indicator and the passcode, and I will take the clock enabler. So so the clock enabler can be enabled. We have 4 rules or 4 conditions. The first rule is, of course, the power should be 1. So yes, the power should be 1, not low, 1 high. And the second condition is giving the clock enabler clock pulse, 1 or 2 or 3 pulses, depending on what floor you want to go. So we also will take an high from the comparator. The comparator should give a high, so the clock enabler also can go high. Also, considering the passcode we added and the card we added, so also the both should give a high output, so the clock enabler can finally give a high output, so the flip-flop can work. My group mates will explain the comparator part and the passcode parts. So thank you.
As my Muhammad friend said, the clock enabler have 4 rules. He talked about 2, and I'll talk about the third one. The third one is the converter. The converter is comparing between the input floor and the current floor here. So if the input floor and the current floor are equal, that means the output here will be low, 0, and the clock enabler will not work. And if it's the same, and if it's different, the output will be 1, and the clock enabler will work. When what the meaning of the same or different? The same, that means the input and the current floor are in the same floor. Like if we pressed here, like if we put like two, floor two. So and the output and the elevator already in floor two, that means that the elevator will not move. But if the elevator in floor six and we want to go to floor two, that means the elevator in the same floor, different floor, so will move, will work. uh, Here also in the door indicator, we connect the output here to the NOT gate for the door indicator. If it's zero, we say that it's the zero. That means that the input and the current flow are equal. That means it's not working. So we'll come here to the NOT gate. NOT gate will convert it to one. One means that the door will open, and if it's moving, that means it's working. Working means that it's one or high. So the output one will come to here to NOT gate. NOT gate will convert it to zero. Zero means that the door is closed. We can have a try. The card, my friend will explain it, but we can like have a try. So we'll make the card high. Also here the bar high, and we will choose floor 3, or we can make it 4, and input here high, clear, 3. So here is we are in floor 7, so you want to go to floor 4, so we'll go down. So we can try 6, 5, 4. That's it. So here if we press again, it will not work because we arrived to the floor we wanted. That's it, and thank you.
Assalamu alaikum, Dr. Firoz. My name is Kinan Fadi, and I am from Group R. So we have this 3-bit counter flip-flop, and my task here is to explain this part right here. Okay, so we have two security features. First one is the card, and the second one here is the passcode. So the purpose of these two features is the output from here or from here will go to this OR gate, and from the output of the OR gate we can decide if the clock enabler will be activated or not. So let's explain the first one. So firstly, the user is required only to use one of these methods, the card or the passcode. Okay, let's start explaining the card. So the card here, the user must key in the value of the card here. If the value is high, it will go to this OR gate. The OR gate will produce an output of 1, which is high. And from here, we can know that the clock enabler will be activated. That's for the first method. The second method here is the passcode. So we can see here the passcode is 001. This is the right passcode we have. Okay. The user here must enter the correct passcode here. Let's say he entered 001 here, for example, and this inputs will go to this XOR gates right here, and the XOR gates will compare if the values entered is matching this right passcode or not. So we will compare the passcode here and the passcode here if they are the same or not. And the outputs from the XOR gates will go into the AND gate. And if it match, the AND gate will produce high, and the high will go as an input in the OR gate. So since we have a high here, the OR gate also will produce high. So high will go to the click enabler, and the click enabler will be activated. Okay, so let's say this method, the passcode, the user inputs, or the passcode of the user was wrong. Let's say it was 000 here, not 001. So the XOR will compare this two passcode with each other, and it will produce and the values from the XOR gates here will go to the AND gates. and since it's not matching, the AND gate will produce an low here. The AND gate will produce low here. So the low will go here to this OR gate. Okay. Then the OR gate will produce an low states. So the low will go to the click enabler so that we know that the click enabler will not be activated. Okay, that is for my part. And thank you for listening, Doctor.
After every one of us explain his part, we will now show you a demo of our lift system and what components my group mate Ali will explain.
So here, doctor, first we have a pre and a clear. Here we have the output Q2, Q1, Q0. It have seven segments. Here we have the E flip flops. The E it's connected to high, and the D is connected to each gate that we get it from the came-up. Like clear is connected to the clear, and the pre is connected to the pre. Each flip flop. Down here, connected to there is four inputs in input floor. We have three inputs: A2, A1, A0. For the converter, we have three gate XNOR. If it's one, it will get one, and if it's different, they will get zero. Here, it will come to the NAND gate. If it's all ones, so it will convert to zero. If it's all zeros, it will convert it to one. NAND gate, it convert one to zero, zero to one. Like we connect the card and the passcode with the OR gate, because the OR gate, if one of them right, we need only one of them right, the card or the passcode. Now we can try to move the elevator. We should make the pre and the clear high. So we'll make it high. Then we'll try once going up and once going down. We'll go up and make the power high, and we'll try the card. The card is high. Here, like we're gonna go to like level 4. Okay, we'll come here to the clock and we'll press. It goes to 1, 2, 3, 4. If we click again, it will not move because we arrived to the floor that we wanted. If we want to down to level 3, not work because the card is not working. If we make the card high, it will go to level 3. We can try the passcode. Here the passcode, there is a number. If the passcode is 001, the elevator will work. We can close the card door. We're gonna try to go to level 6, and the input will make it high to go up. 1, 2, 3. We arrived to level 6, and that's it.
Okay, thank you, doctor. This is our demo for our lift system, and we hope we covered all the materials you want. And thank you. Okay, okay, doctor. So after every one of us explained his part, we will now show you a demo of our lift system and how it's work and what is the deeds components that we used in it. My group mate Ali will explain.
So here, doctor, first we have a pre and a clear. Also here we have the output Q2, Q1, Q0. It have seven segments. It will display seven segments. Here we have the E flip flops. Here the E it's connected to high. It's connected to high, and the D is connected to each gate that we get it from the came up. Also here the clear is connected to the clear. Also and the pre is connected to the pre. Each flip flop. Down here we can see AND gate. It's connected to. There is four inputs: clock and power and comparator, also the comparator and the card. Here we can show we can see in input floor we have three inputs: A2, A1, A0. Also, you can play. And here we can see for the input floor, we can see A2, three inputs: A2, A1, A0. They display seven segments also. For the converter, we have three gate XNOR, because if it's both, like if it's 0 0, it will get 1. If it's 1 1, it will get 1. And if it's different, they will get 0. Here it will come to the NAND gate. It will convert it, like if it's 1 1, if it's all ones, so it will convert to 0. If it's all zeros, it will convert it to 1. And here NAND gate, it converts 1 to 0, 0 to 1. Also with the card, we connect the card and the passcode with the OR gate, because the OR gate, if it's one of them, it's right, it can work. So we need only one of them, right, the card or the passcode. Here we can, now we can try to, like to move the elevator. We can start. We should make the pre and the clear high. So we'll make it high, then we'll go down. For the input, we'll make it 1, because we want to go to, we'll try to one, we'll try once going up and once going down. So now we will make it 1, so we'll go up, and we should make the power high, and we'll try the card. We have the card, so the card is high. Here, like we're gonna go to like level 4. Okay, so we'll come here to the clock, and we'll press. It goes to 1, 2, 3, 4. If we click again, it will not move, because we arrived to the floor that we wanted. We can try without the card. If we try to without the card, like we want to go to level 3, we'll go down to level 3. It will not work because the card is not working. If we make the card high, so it will go to level 3. We can try the passcode. Here the passcode, there is a number. If the passcode is 0 0 1, so the card, the elevator will work. We can close the card, like make it low, and here it will be like 0 0 1. So we're gonna try to go to level 6. So we'll make it up here for here. And the input will make it high to go up. So we're gonna try. Oh, sorry. 0 0 1. So I'm gonna go up. 1, 2, 3. We arrived to level 6. And that's it. Thank you, doctor.
Yeah, thank you, doctor. This is our demo
For our system.
for our lift system, and we hope we covered all the materials you want.
Here, doctor, we can see the circuit 2. Here we can see this one, the comparator, and here the counter. We can see the clear up down button and load button. Here the clock. We can see also the inputs. There are three inputs here and three outputs here. There is the converter finishes process, then send it to the counter. So we can try to, like,
Could show us a demo.
yeah.
Yeah.
So we can, here we will
Set
give
the
the
clear
clear high, and we want to go like up.
You can make the input for the level 4.
Yes, we can try to level 4. Then we can give the pulse 1,
2,
2, 3,
4.
4, and that's it. If we click again, it will not work because we
Alright.
arrived to level 4. If we want to go to like down to level 1, so we'll make it down
Down. Clock.
3,
So
2.
it requires only 3 pulses here.
Yeah.
Look.
Here, so as we said before, when it's equal, the converter will get 0. So that's meaning that they are equal, the input floor and the current floor. That's it, and thank you.